Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and in this video we're going to be solving a quick and easy equation about complex numbers. So we have z plus 2z bar, which is the complex conjugate of z, equals 2 minus I divided by 1 plus 3i, and we're going to be solving for z values. Now, this is a really nice problem, and I think it's good for beginners. If you're new to complex numbers, you can also check out my lecture videos. I made a playlist along with a bunch of other problems. And if you have any questions, always feel free to let us know in the comment section on any video. Great. So this problem is actually from a really nice book that my friend gifted me today. I'm deeply grateful for the gift. It was a beautiful book he used a while ago while he was doing his master's, and then he gave me his copy. It's a really nice book because this is actually a really easy to read book, and I believe the Math Sorcerer made a video about this, and this is a really nice, easy to read book on complex analysis. Hopefully I'm going to be able to pick a lot of problems from there and share with you guys. The authors are Dennis Zill and Patrick Shanahan. Is that how you say it? Anyways, it's a really nice book. Check it out. And now I'm going to go ahead and take a look at this problem. So we have z plus 2z bar equals 2 minus I divided by 1 plus 3i. The name of the book again is A First Course in Complex Analysis with Applications. So, how do you solve such a problem? First of all, we have a quotient on the right-hand side, which we can simplify. And it will be a really good thing to do. Let's go ahead and simplify it by using conjugates. Now, how do you simplify division, or how do you divide complex numbers? You cannot divide them like polynomials or real numbers or integers or decimals. You can just pretend that you can multiply it, like say, okay, this quotient also needs to be a complex number, and I can set it equal to a plus bi or x plus yi, whatever, and then hopefully from there I can find x and y, right? By cross multiplying, you'll get, the values of x and y, you'll get a system. That's very long though. There's an easy way to do it, which is by using conjugates. We can make it a nicer complex number. Multiply by 1 minus 3i. The conjugate of a complex number is basically found by negating the imaginary part, and it's just the real part stays the same. And for that reason, the conjugate of real numbers are themselves, because they are real numbers. Okay, I hope that makes sense. Let's go ahead and distribute. We're going to get a 2, and then 6i, and then minus I, and plus 3i squared, which is minus 3, divided by, the bottom is difference of two squares, which turns into a sum of two squares, because I squared is equal to negative 1. So this is 1 minus 9i squared, which is 1 plus 9, which is 10. Awesome. Now we're going to set it equal to left-hand side and try to simplify the top. This is negative 1 minus 7i over 10. And here we still have the same thing. Now at this point, how do you solve a problem like this, right? The general method is, by the way, there are two ways to approach this problem. I think I'll show you both. So the first method would be replacing z with a plus bi. Why? Because z is a complex number, and z bar as a result becomes a minus bi. Let's go ahead and plug it in. Notice that there's a 2 here. A plus bi plus 2 times a minus bi. And now I can go ahead and separate the real and imaginary parts, which will be helpful in our calculations. Now, we're going to put together the real parts. From here, we're going to get 2a, and that's going to give us 3a. bi minus 2bi is going to give us minus bi, and that's equal to the right-hand side. And now we can go ahead and compare directly. 3a is equal to negative 1/10, which means a is equal to negative 1/30th, right? That's the value of a. To find b, you're going to set it equal to 7/10, and b is going to be 7/10. Easy, right? And remember, we're looking for z, and z is equal to a plus bi. A is equal to negative 1/30. b is equal to 7/10. So z should be this, if I didn't make any mistakes. Okay, hopefully you're gonna check, right? Now if you go ahead and test it out, like plug this in to the original equation, you should get a solution, right? You should get what's on the right hand side. Also use the simplified version, which will be easier to check. Make sense? Okay, this is the first method, and let's go ahead and take a look at the second method. I think the second method is also really cool, but you're gonna decide which one is better. And again, we can just start over, but we already know the answer. Let's go ahead and just set it equal to that -1/10 plus, what was the other number? Minus 7 over 10i minus 7 over 10i. And now we're going to set it equal to that. So let me go ahead and write this directly. And here's what I'm going to do. Did you guess my second method? Okay. Don't say it if you know it. I'm going to use the conjugacy properties. Is that the right word? Like properties of conjugation. So we have this equation, and then I'm going to copy that one more time, because what I'm about to do is I'm going to conjugate both sides. When I conjugate this and that, they're going to be equal, because if z sub 1 is equal to z sub 2, then their conjugates are equal for obvious reasons. Here we have a sum. Again, we have the properties of conjugation, which says, okay, if you have the conjugate of a sum, it's the sum of the two conjugates. In other words, this is going to turn into z bar plus 2z. Product is unaffected because 2 is a real number. And on the right hand side, we're going to get -1/10 plus 7 over 10. I remember, you're only changing the imaginary part. So that's one of my equations. And then along with the original equation that we simplified, oops, I keep writing a plus sign there, we have a system, right? Now this is my system, your system too, of course, right? Our system. And we can solve it. How do we solve it? Probably by substitution or elimination. In this case, I would probably say elimination is a good idea. I don't think substitution will work well, because you're going to imagine replacing z with something that's going to look complicated, right? I don't know. That's my thinking. So let's go ahead and see what we can eliminate. I think I would eliminate z bar because I want to end up with z. So let's go ahead and multiply the top equation by -2 everywhere, and then write the results here. -2z bar minus 4z equals 2/10, which is 1/5, minus 14/10, which is 7/5, and multiply by, of course, the sign will change. And then just copy the second equation as is, and then combine these two. Okay, great. Now we're going to get, first get rid of these. Z minus 4z is -3z. 1/5 minus 1/10, that's 2/10, so it's gonna, the difference will be 1/10. And that's like 14/10, but they're both negative. -14 and -7 is going to make -21 over 10i. And now the next step would be dividing both sides by -3, and that will be -1 over 30 plus, we divide 21 by -3, -21 by -3, that's going to be a 7. So we're going to end up with 7 over 10i. Now, is that the same result that I found with the first method? Hopefully, better be, right? -1 over 30 plus 7 over 10i. Yay, great success. So we hopefully did not make any mistakes. If you know of a third method, please let us know. But this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.